Hi, this is my practice speaking English and I'm talking about game development. Today I'm not going to develop and I'm going to explain my game and game design. Yeah, and I've written this document today in Japanese and from now I'm going to explain it. Yeah. And yeah, before start to explain it, you need to know about the game rule, and the game rule is explained before, but um, yeah, but if you get interested in this game, I will explain the game rule. So yeah, feel free to comment. But I think there is no viewer. Yeah, this is my personal training. Yeah. So I'm going to start to explain. Yep, game design, and at the beginning I'm explaining the game design as a game developer in this page, and I'm glad to refer to this page when you play the game. Yeah, because in this page there are many there are important information about the game. So yeah, you you should read it before starting the game. And the foundation of the game, um, to acquire shell capacity, there there are two types of resources, that is shell capacity and data fish, and players aim to maximize their own shell capacity. Yeah, that is the win condition. And there are three ways to acquire shell capacity. The first one is shell capacity self recomposition. Yeah, this is like interest. And second is to parse data fish. This is like exchange data fish to shell capacity. Yep. And the last one is reward of mission. Yeah. About UPB. UPB stands for unit per B, is amount of shell capacity when the 1 BI worth of data fish is parsed. Yeah. And this value is calculated based on the ratio between total amount of data fish and total amount of shell capacity. If the ratio is 1 by 1, UPB is 1. If the total amount of shell capacity is 10 times of data fishes, UPB is going close to 0.1. Yeah, because the ratio is 10 by 1. Yeah. And this value is updated when purging or imprinting happens. That means exchange happens. And compare the amount of acquiring. Compare increase. The cell capacity self recomposition is compound, so you can acquire the cell capacity like this, and so at the end phase of the game, the player likely to have a lot of amount of cell capacity, so the increase of self recomposition is exponentially increasing like this. On the other hand, to acquire data fish, the amount of data fish to increase is based on the density level in the area, and yeah, the density level is the density level is going up to max for 10 logical time at first. Yeah. Yeah. There is areas. There is areas, and areas has a density level that indicates the efficiency to acquire data fish. Yeah, and also there is a time concept which is called logical time, and this x-axis is logical time, and if you play very well in 10 logical time, the density level is going to reach to max level, and then the data fish is going to increase at most efficient level. Yeah, but at the same time, this means the amount of data fish to acquire is not going to more than this, so which means the increase amount is saturated like this. Yeah, and this graph shows the comparison of the amount of shell capacity, self-recomposition, and data fish, the amount of data fish to collect. In this example, at the 10 logical time, the density level reach to the max, and at the 20 logical time, the player parse data fish to shell capacity. So the data fish is going down to 0, and the amount of data fish is converting to shell capacity like this. This is a simulation. And as you can see, after 20 logical time, the shell capacity is going up exponentially, because this value is going up by compound interest. The data fish is still going up by max efficiency. The data fish, the efficiency to acquire data fish is dependent on area, the density level of the area. So this is not dependent on the amount the player have. So if you have 0 amount of data fish, it is not related to the amount to acquire. The data fish is going up by same efficiency. And the reduction of UPB. UPB means unit per BI. And let's think about the situation where 4 players joined the game, and the first player is playing like this. So the player exchange the data fish to shell capacity at 20 logical time, and there are 3 remaining players, and they still have data fish. So the data fish, let's assume the data fish is going up to like this, because they are having data fish. They still have data fish. They never change to shell capacity. In that case, UPB is going up. UPB keeps over 1 until 40 logical time, because let's think about they still have data fish. The remaining 3 players have the amount of data fish like this, because increasing linear. So So like this. So there are 3 players to have data fish about this amount. So simply 3 times this value, 1, 2, 3. So the total amount of data fish is larger than total amount of shell capacity. So in this case, UPB keeps over 1. UPB larger than 1. Yeah. And next, if the another player, one of the remaining 3 players, exchange parse data fish to shell capacity like this. So in this case, this player, the first player, exchange data fish to shell capacity at the time. How is the UPB? The answer is it's about 3 or 4. 3, because the data fish, the remaining 3 player has data fish. The amount is like this. So simply 3 times 1, 2, 3. So the ratio is 1/3. So UPB is updated to 3. Okay. And yeah, in this situation, the second player want to exchange data fish to shell capacity like this. UPB is 3, so the second player can exchange so efficiently. Yeah, it is going to 3 times. So let's imagine the purple line is going up to third times, 3 times, like this height, and at this height the increase speed is so high, so like this, like going up. So at this point, the UPB is going down, because the amount of shell capacity is larger than the amount of data fish at the time. After the second player exchange data fish to shell capacity, shell capacity is larger than data fish, so the UPB is going down. UPB is less than 1, so it means the exchange rate is bad, so bad. And then, as you can see, the amount of shell capacity is going up by by good speed, On the other hand, data fish is not good compared with shell capacities. Yeah. So the thing is UPB keeps going down and it never going up. Okay, because shell capacity is so large. Yeah. Okay. This is most important message. Yeah, in this page. So the foundation. Um, so the foundational theory that can be de- derived. Um, the players likely to exchange data fish to shell capacity by the time the UPB is going down, going worse. Yeah. This is important. On the other hand, in this game, the players who have a lot of amount of shell capacity are likely to take disadvantage and many risks. Yeah, this is a game design, so this balance is so important, and I assume this balance is the core of the game. Okay. Yeah. And next topic is game phase. And first of all, let me explain about time. The game duration is set to 15 or to 20 minutes, about 20 minutes, and there is a concept of time called logical time, and the game ends at 127 logical time passed. With so let's think about how many logical time passes per minute. This is a simple formula. 127 logical time divided by 20 minutes. The answer is 6.35 logical time per minute. Yeah. This is a average value, and with the assumption that one taking action takes 15 seconds, um, the 1 minute can have 4 logical time, but at the end of the game phase, the logical time by one action is going up in this game. So I think 127 is good as a game duration. And also I'm talking about background settings. The 172 comes from the value of the register in the for the logical time counter in CyberOcean. Yeah, I mean, the register have 7 bits, so 2 power of 7 is 128, but we can include 0, so 0 to 127. Yeah, this is a background setting. It's not important, but yeah, I want to explain it. Okay, and at the beginning of the game, how is the game going? Yeah. To take an advantages during the game, it's important for players to have a lot of data fish. So at the beginning of the game, it's important to increase density level. Density level is effect density level is related to the amount of data fish to acquire. Yeah. And in order to increase density level, it is needed that two players are in the same area. Yeah. So I assume 2 players are going to the same area, and also if it is these players can start the virtual sharing, and which makes them take more advantages. Okay. And another thing, the player can build strategies at the beginning of the game, because the initial location the player placed is random location. So it is important to make a strategy. For example, Patch Terminal is a place to parse data fish. So if the parse terminal is far from you, the the other player might going to might go to parse terminal early or early than you, and other player parse, and then UPB is going down. Yeah, as yeah you see this graph. So other players go to parse terminal and yeah parse in advance so UPB is going down. Yeah, so the player who are far from parse terminal is should make a strategy and consider the situation. Yeah, in this situation, this player, I think this player should have a lot of strategies. I think this is important important indicator to how interesting the game is. Yeah, so I want to design the game this player so that this player can have many strategies. And next, the middle or end of the game phase. I'm thinking about this after this phase. So the amount of the data fish is going up, and player can exchange data fish to shell capacity. Yeah, the players is ranked. Yeah, top ranked player, or yeah, like that. So let's think about patterns to win. A pattern. Pattern A is to parse early parse and self-recomposition. The player can how to say yeah, early parse and self-recomposition, aiming to win by maintaining the top position in total holdings. Total holdings, or yeah. Trying to secure victory by holding the most share capacity like this. Yeah. Okay, and pattern B. The player um, player is only able to try come back by share feature or completing missions because the UPB is already going down and so worse. Yeah. So like this player. And pattern C is a hybrid A and B. Not top, but can parse data fish and some can acquire some amount of share capacity. So this player might be second ranked, yeah, and yeah, aim to win. The top ranked player might fail something. Yeah, so there are three types. And let's think about design and strategy. From now, I'm thinking about uncertain elements in the game. Yeah, I'm talking about in my brain. Yeah, I'm not sure the game is actually going like that, or yeah. So yeah, but yeah, I'm going to explain my expectation or assumption, and also I should design the missions to make the game more interesting and well balanced. So this is a mission design 1. I want to design the mission so that the B pattern player doesn't have the risk. Yeah. So, for example, I want to create a mission where the player need to go to a certain place to complete the mission. This means there is a share feature. Share feature means if the two player go to the same place, the amount of share capacity is divided equally by the two players. So this means player who have less amount of share capacity doesn't have a risk, because if the share happens, the amount of share capacity is divided by 2. So the player who have a lot of share capacity have a risk, because they because they need to give share capacity to another player. Yeah, so this mission, yeah, this mission makes what I want to I want to this mission is what I want to make. Yeah, for example, imprint terminal or copy terminal is the only one place. So in the mission, the player needed to go this place. The share might happen. Yeah, this is one of the mission design. And mission design 2. This is similar. I want to create a mission so that the top ranked player have a huge risk. By this design, the player might aim to be second ranked because top ranked player is likely to have a lot of huge risk. Yeah, and as a result, I want to create a situation the all of the player close to each other. Yeah, because they are not they don't want to be top ranked. Of course, the player who have a lot of share capacity and top ranked overwhelmingly, absolutely top ranked, the player can win the game. So I call risk. So the risk is the risk does not always result in penalty, right? Yeah, so there is a huge risk, but the player can avoid the risk. For example, the mission the top ranked player might reduce share capacity to 100 amount if the top player is triggered with share feature or siphon share by the time a certain logical time passed. Can that make sense? So there is a top ranked player and the other player are going to attack or setting up trap. These are called sharing. Sharing means go to same place, and siphon share means like a setting up trap. So the top ranked player go to certain place, the siphon shell might be triggered. Yeah. If the trigger is happened, the amount of shell capacity the top ranked have is reduced to 100. Yeah, almost zero. Yeah, this is a mission. Yeah, in so there is a possibility to happen this mission. um, the pattern B player have a strategy to set up the trap siphon shell at the beginning of the game. Yeah, because if this mission happens, the trap is there are so many traps works for top player. So I think this is good. Yeah, for the pattern B player, they have only yeah yeah. So this gives the player the strategy, one of the strategies. So I think I like this mission idea. And let me explain strategy. Aiming to be second. So as I said, after first patch, the UPB likely to going up. So second player can purge and can choose choose options. The first option is going up to top by purge all of the data fish with good efficiency. And option 2 is how do I say? Option 2 is deliberately staying in second place, or to going to second place in this case. Yeah, so you can choose the amount to purge. So yeah, you can calculate and purge some amount of data fish, and yeah, aim to go to second place deliberately. Okay, and next, mission design 3. I want to create a mission where the team need to collaborate. The player need to collaborate with other player in the team. And if the mission is not completed, the team fail to complete the mission, um, the penalty is given to the team. The penalty is uh, to to lose to lose some percentage of shell capacity the player have. Yeah, in this penalty, the player who have less shell capacity, the penalty is not huge penalty, right? Because they have a small amount of shell capacity. So yeah, the amount, the penalty is not bad. So for these kinds of players can fail the mission deliberately. Yeah, this cause to lose the amount of shell capacity the teammate have. So if the teammate have a lot of shell capacity, the player who have a small amount of shell capacity fail to complete the mission deliberately. Yeah, this is a kind of strategy. Okay. And next, interrupting purge. Yeah. Until now, I'm talking about the negative part of player who have a lot of shell capacity. But on the other hand, the player who try to come back should have a risk. Yeah. So as a risk, I want to introduce to interrupt purge. So purge means data fetch to shell capacity conversion, and the player who have a small amount of shell capacity take a strategy that purge data fetch to shell capacity at the end of the game. So yeah, to avoid the risk, the player plan to purge at the end of the game. Yeah, but there is a risk. Yeah. The game is end with 127 logical time, so the player think about the time, logical time. So count the logical time and plan to purge. In this case, the logical time might go fast. That means normally logical time passes by 1 to 3 at one action, but yeah, as a risk, the logical time might pass by 5 or 10 or something like that. So the plan is broken, yeah, if the logical time go fast. Can I make sense? This is one of the what I'm thinking about interruption. And next, mission rewards. Yeah, this is important because this type of player is depend on the mission rewards, so the amount of mission rewards is so important, in the game design. And in my current opinion, the amount of mission rewards is the total amount of shell capacity when the mission is generated. So if the mission is happened here, the total amount of shell capacity is like this. So this mission is completed, the player who complete the mission can acquire this value, about this value amount, this value. Approximately like this. There is an adjustment, but approximately total amount of shell capacity at the time. So it means the mission at the end phase of the game, the reward is so high because, as you can see, the end of the game is so going up. Reward amount is so high, so the mission is directly connected to win. I think this expression is not correct. Directly connected to. Okay. Leads to victory. Connected to winning. Okay. This is the game design about my game, Selfish. And in my opinion, I think the A type of player is strong, have a strong strategy in this game, because exponentially increasing. So I want to create a lot of process to interfere the top ranked players or players who have a lot of shell capacity, and as a result the type C player is a main type. I think this type of player is no. I think players likely to choose a strategy of type C. This is a hybrid, so deliberately stay in second place and waiting for top player failure. Yeah. This is my expectation, and for at last, yeah, I want to create a game where there is this is difficult. Dramatic, epic. I'd be happy as long as the game allows for that dramatic win, holding just data fish and bring off a comeback in the end. Okay? Yeah. I like the player who aim dramatic win. Yeah, so I want to cheer them. Yeah. Okay. Thank you for watching. Today I finished the video. Yeah. But I need to improve my English, I think. Yeah, it's so important to so difficult to explain, and I'm not sure this explanation is understandable. Yeah. So in the future I want to explain this page again. Yeah, and I want to check my progress about English improvement, English speaking. Yeah. Okay, so that's it. Thank you for watching.